Hi everyone, daily.dev episode 22. I think we have amazing speakers and this episode will be about backend development. So I'm super happy. I see people here. I always love the intro theme songs. It always pumps me up. So today we have, as I said, three speakers, Dennis, Sabrina, and Simon. So how are you? Sound check for everyone.
We're all good.
Nice.
Hey,
Perfect. See so many people. The doctor think it's quiet. Let's get started. Wow. So many people already. Perfect. So before we start, something very super important. This is vital. This is top priority. So if you want, you can check it daily.dev. It's free. It's a way to stay up to date as a developer. But in this episode, I want to really say that we have a meme contest when you can basically win swag by submitting a meme. I highly recommend also the speakers to join this. If you want to participate, we will make a live stream when we will make the judgment. If you want, Dennis, if you also can come. And you can go on this repository, you can just submit a meme. It has to be developer related. There is also a link to what a meme is in case you don't know. So that's it. It's very easy to join. And yes, that's it. I'm a bit sad because we could create an event based on memes. Maybe this can be also an idea for the future. And the link is on the pinned message in the chat, but I'll share this again. No worries, it should be here. Yes. Perfect. So let me remove this one. Okay, so today, one second. Let me share the screen. There we go. Okay, so about backend development, we will start with Dennis Ivy. Finally, I host you again because the last time you invited me like 3 or 4 times. So, and we will talk about API. So, what is an API? We will focus on the Django part, of course. And then we should have, let's take this one. We have Sabrina from Shakudo, and I can't remember the title, should be this one, Train, Scale, and Deploy a Machine Learning Pipeline in 25 minutes with Shakudo. It sounds like a challenge, so I want to see Sabrina. And last but not least, Simon, Choose Your Own API Adventure with Platformatic DB. I really love this title, but you have to wait till the end, Simon. So yes, perfect. I also love this profile picture. Nice, perfect. So let's start. I see many people here. So, okay, hi everyone. How are you? Let's get started. Perfect. So how does it work? All the speakers have 25 minutes for the talk, and we have 20 minutes, and then if we have some time for the Q&A. That's it. And so we'll start with Dennis. So let's say bye to Sabrina and Simon so we can get started. Bye, everyone. Bye. Okay, Dennis. Finally, we are making a live stream again. I think we made many.
We're probably over 5 by now, at least.
I lost count, and this is a good sign. I'm super happy. Dennis is a YouTuber, freelancer. Now he's also a developer advocate at Agora. He organizes hackathon. Organizes hackathon because now I have Oktoberfest in my brain. But he organizes hackathons. And what else, Dennis? How are you?
Yeah, so I'm doing awesome, Francesco. Awesome to be here. Quick background. Yeah, I have my own YouTube channel, Dennis Ivy. I also am a contributor at Traverse Media. I help Brad run that channel. So you'll find a few of my videos on there if you want to know more about Django specifically, because that's what we'll talk about. I have a pretty long course out there. It's like 7.5 hours on his channel. And I'm also a developer advocate at Agora, something that I didn't know was even a job until about November of last year, and absolutely love my job. I get to advocate for Agora, show people how to use their SDKs to build out audio and video chat applications, real-time data signaling, and so on. So yeah, a lot of fun. Love what I do there. So
yes, I see. Being a developer advocate, it's really it's a great job. I can say it is. And yes, so Dennis, if you want, you can start sharing your screen. I see people here. Simon is also in the chat. Well done, Simon. I see Farid here. And yes, we have great presenters today, so the pressure is increasing. And yes, so let me see here. We have also Graham, backend development. Yes, perfect. Okay,
right.
Perfect.
So Dennis. This is the introduction. I also have my website, DennisIvy.com, not .co. That's a mistake there. So I'm going to run through a few slides. My title is going to be a little bit different from what the cover here says. I was going to talk all about APIs and REST APIs, decided to do a quick overview on that, and then actually just show you how to use a backend application, kind of fit more of the theme here. Francesco, sorry, were you saying something?
Dennis. No, I just want to leave the scene. So, but in the meanwhile, I'll check the real link and I'll post this in the chat. So no worries. Bye, Dennis, and good luck. Bye bye.
Alrighty. So if I go over time, Francesco will let me know. I'm going to try to keep this within 25 minutes. So what we're going to do here is we'll talk about APIs and why we need them. I'll do a quick introduction just in case somebody maybe is a little bit newer, doesn't understand, because I do know there's some confusion about this. And then we'll actually go into building an API with my favorite language and backend framework, really a full stack framework, Django. So first of all, what's an API? There's all these technical definitions, and really after you read them, you feel like you get nowhere until you talk to somebody or see it in action. It stands for Application Programming Interface. The way I like to describe it is I just say an API provides an access point for communicating with some kind of server-side application or a backend. That's really all it is. It's simply an access point to talk to an application. So for example, let's say we had an API for some kind of social network and we had users. If you look at this example here in the slide, you would go to some endpoint like mywebsite.com.api and then users. So that's like the URL, the endpoint, and this would get you back an array of users in JSON format. You usually use XML or JSON. More commonly, it's JSON data. Looks a lot like JavaScript, stands for JavaScript Object Notation. If you're a Python developer, it looks a lot like Python dictionaries, and that's how you're going to get back that data. Now, in this example, if you use a GET request for the HTTP method to get back a single user, you would hit an endpoint or a URL like users with an ID, and that's going to return back a single user. So you basically have these set of rules and endpoints that you can access to work with data, get data, and even send data to a specific backend without really needing to know how it even works. Backend developer develops the API, a front-end developer can access that API, and they're really stateless in the sense of where they don't need to know about each other, they just sort of communicate. So I like this example. It's kind of like Fireship's video where he has that JavaScript code this, not that example. That's kind of what I followed. I don't know if anybody knows that specific thumbnail, but this is what I'm going to base the example off of. And essentially, this is going to be my JSON data. This is going to be some kind of request that I'm going to hit on a backend, usually that user's endpoint. I'm going to get this data, and then as a front-end developer, I'm going to convert it into something like this that you see on the right here. So this is actually a live website that I'm actually going to demo here in a second, but this is how we're getting the data and then presenting it. Now, when do you use APIs? I get this question a lot because there are more like full stack applications like something like Django where you don't necessarily need to build an API. You can actually use the Django templating engine. But in this example, I'm going to basically highlight three main areas where you might need an API. First of all, in my own applications, this is when I use it. When I'm trying to use a front-end framework like React, which is my favorite, there's Vue, Svelte, there's Astro, then one of the newer ones. If I'm using one of these front-end frameworks, I'm usually going to need to have some kind of data to provide and then access within that framework and then render out. And I'm usually going to need an API within my own applications. Also, if I'm working with a team of developers, which I've worked on both sides of this, where I've been a backend developer and a front-end developer, let's say we have two developers and we have a backend developer and a front-end developer that don't know each other's crafts, but they do need to work together to build out this application. The backend developer would typically build out some kind of API, give a set of rules and endpoints, and tell the front-end developer how to communicate with that. And then these two can actually build out an application together without needing to know about each other's jobs. Another example is a public API. For example, recently I was actually working with a Twitter API. I got back some public user data, something like a weather app, maybe stock data. I can access a lot of public APIs, some free, some paid, but I can get data and then build out my own application. So somebody builds an API and then multiple people can access that. So that's something like a public API, and I've built those out too. And also I'm going to show an example of what that looks like. So this is a live example right here. If you want to, if you're on a computer and want to follow along here, if you go to kados.dev, this is actually a project that I hacked together last weekend, and it's simply a website that went and scraped some Twitter data. I'm going to use some LinkedIn data here soon too, but I basically found all the developer advocates that I can find using my web scraper and the Twitter API and built out my own API using the Django backend. So if you go to this website, you're going to see the front end part of this. But if you look at the top right of this site, and I'm actually going to open it up in a second, you're going to see a button that says get user data, and you're going to see the API version of this. So this is what I'm going to code here, not the full application, but I'm going to code a very minimalistic version of this. So if I close out these slides, let's go ahead and open this up. So this is kados.dev. If I scroll down here, I can search all these advocates. For example, if I want to see all the developer advocates at Agora, I can run this search, and here I should be able to find my entire team. So these are all the developer advocates at Agora. So this is all being provided by this API. So if I open up this demo, the data that I'm accessing looks like this. And I'm going to try to zoom in here a little bit just to make sure everybody can see this. If we compare it to the data we see here, if I actually remove this search and start over again, we're going to see myself and my coworker Tadas actually be placed in the top 2 results. Now, if you look at the data here, you're also going to see my name right here. You see my bio, my Twitter account, and then you're going to see another JSON object for my coworker Tadas. We actually see Francesco here because he's listed out down here. So that's the API data. That's the front end. I hope I didn't over-explain. I just wanted to make sure everyone kind of gets that concept. We're making these requests back and forth, and these 2 applications can work together. So what we're going to do next here, if I go back to my slideshow, is we're going to go ahead and jump into the code along section. It's live coding. What can go wrong? We'll see how this turns out. But essentially, we're going to talk about the prerequisites. I'll install Django, and we're just going to start building out our first API response. We'll build out a database real quick, serialize that data, and then render out those query sets. If I have time, I'm going to add in some quick search functionality to that. So let's go ahead and start live coding. So I'm on a Mac here, so I'm going to go ahead and open up my terminal. If anybody in the chat, or maybe Francesco, can let me know if maybe I need to zoom in a little bit, just let me know, and we'll just try to adjust things if you can't see it. So first of all, the prerequisites here, we're using Django, which is a Python-based backend framework. So we're going to need to make sure you have Python installed. For anybody coding Alon, maybe after this video is posted, I'm sure people won't code Alon live right now. You're going to need to make sure you have Python installed on your computer. Once you have that, you will have access to the pip command, which is the equivalent of like npm for JavaScript developers. And you're just going to want to run pip install Django, and this will give you the latest version of Django. So while that's happening, well, I guess I already have that installed. We have Django installed, and once we have that, we have access to the Django commands. And to set up our first Django project, we just do Django-admin start project, and we're just going to call this Django _ API. So that's going to be our first application. It's kind of like the create React app command for anybody that knows that. It's going to give us our boilerplate files. And if we look on our device here, on our computer, grab too many files here, we're going to see this folder here, and I'm going to go ahead and open this up in VS Code. So it just gave me a boilerplate file here, and we're just going to open up a new VS Code project here, or a new instance of it. And we're just going to go ahead and find that on my desktop. So here's my Django API. I guess I can't zoom into that. And this is the project. So I'm not going to go into explaining everything as I'm doing this. We're just going to do a little code along. I'll try to zoom through real fast to get this set up. But this is my Django project. We'll go ahead and start our server. All we have to do is go ahead and run Python manage.py run server. Try to zoom in here. And Django has a built-in server, so that's just going to go ahead and start this up, and it's going to tell us it's on port 8000. So we'll just make sure everything's working before we continue. So let's go ahead and open that up, and the setup is the part that usually takes the longest here. So this is our first Django application. Okay, so let me just go ahead and move this to another window. Give me a second. You know what? I'm just going to go ahead and just move that to the other screen. Okay, so while we're doing that, and by the way, if you're not using VS Code, you're going to want to CD into that project. We're just going to go ahead and open up a second terminal within our Django application, and we need to create a Django app. So we have our basic project structure, but we also need to create an app, and this is where all the core functionality is within our project here. So this is going to be with Python manage.py start app. So just like the start project command, we start an app, and we also have to give our app a name, and I like to start with just base as kind of a generic name. If I'm not separating my project into multiple apps, that's how we'll keep it. So we have our project and our app, and that's going to create some boilerplate code within my project here. And the first thing I need to do is go into this file called settings.py. I just need to configure this with my Django project here. So we'll go into here. This is like your package.json file in like in a Node.js project or in a React application. So all we need to do is go into this installed app section, add in the app here, and then we're just going to go ahead and return our first response by creating a route. So within our app here, I'm going to go into this views file, and we're going to create a couple of views. Views are just functions that return back some kind of HTTP response. So we're going to create a view called endpoints. And here I'm just going to specify, or I'm going to have a view that tells me all the endpoints that I have on my website or URLs here. So when you first go to my API, you'll be able to see the routes that you can access. So we create the function, we return, and with this, we're just going to return back a simple JSON response. So we're going to make an import from Django.http import JSON response. And what this function is going to do is going to go ahead and get any data that we pass into it. In this case, we're going to pass in a Python list. So we'll just do endpoints, or we'll just do we'll call this routes just so the names aren't conflicting, and we'll create some kind of list here. And we're going to have an endpoint that goes to users, and then another endpoint that goes to users, and then we'll pass in a dynamic value like ID. So what JSON response is going to do is it's going to go ahead and take in this value of routes, and it's just going to go ahead and turn this into a JSON response as opposed to a Python dictionary. So it's just going to convert it to JSON data. And then we also have to pass in this value of safe. That basically means that we can pass in more than just, I believe, a Python list. So we can pass in a little bit more. So we do have to specify that, and that's it. So this is our first view, and all we're going to do is return this value. So with that, we also need to create some URLs here. And with Django, we're just going to go ahead and within our app create a URLs file. This is going to be the actual endpoints that we're going to have. So this is going to be urls.py. And I'm going to need to go ahead and do a few configurations here. So from Django.urls, import path, and then we're going to import our views into this file because we need to know which view to trigger when we go to this specific endpoint. So from dot import views. So we're just going to import all the views here. And then we have a Python list here. And essentially, we're going to have a list of URL patterns, and whatever path is matched within the browser, that's going to be the view that responds according to what the user is visiting. So right now, if we leave this as an empty string, that's just going to be the home view. And we're just going to go ahead and say, whenever a user goes to this homepage, go ahead and trigger the endpoints view. So we have a view right here. It's called endpoints. Whenever a user goes to the homepage, go ahead and fire off this view and return this JSON response. So this is a very minimalist API here. And with Django, the weird thing is we can have multiple URL files here. So we actually have to go within our main project, and we have to go to this URLs file, which already has some setup for us. And we simply have to include that main URLs file. So here we're also going to leave an empty string, and we're going to use this method called include. And what include is going to do is it's going to say, go ahead and anytime this endpoint or this path is matched, which is going to be our base URL, go ahead and send all this traffic to the base app that we created, and then send the user to the URLs file. So we're saying, go ahead and let this file take care of all the routing. Okay, so that setup is the hardest part at this point. It always takes the longest. One of the things that people complain about Django, but honestly, once you're past this, you're going to see so much value in what this framework gives you. So to run the server, well, we actually have it set up already. Actually, I just closed that out. So Python manage.py run server. So let's get this going again. And URL patterns. It looks like I have a spelling error somewhere. URL patterns. My first mistake with live coding here. All right. So now if we go to this endpoint, we're going to override this. We're going to override this default page. So if we zoom in here, we go to the home page, and now we see this JSON response. So that is our basic API. So what I'm going to do here is create a few more routes, and then we're going to use a framework or a package that's built on top of the Django library here that basically puts a wrapper over it and makes for developing APIs a lot faster and gives us a lot better functionality from what we currently have. And I'll explain what that does exactly in detail here. So let's go back into our views. Let's create a few more endpoints. So we're going to go ahead and create an endpoint called users or user underscore list. And this is going to give us back an array of users. So we'll just go ahead and create that, return. Then we'll just do the JSON response again. And at this point, we're just going to do data here. So we'll just pass in data. And that's going to be a list of advocates. So we'll just do my coworker Tadas, we'll do my coworker Max, we'll just return 3 users, and then myself. So these are going to be the Agora developer advocate. So all I need to do is pass in data to JSON response, add in safe, set that to false, and that's going to be my second endpoint. I'm going to duplicate this, and I'm going to create an endpoint for a specific developer advocate. So let's say I have a front-end developer, and I need to set up all the routes for this developer. So we're going to create another endpoint called user detail, and this will give us the information about a specific user. And at this point, what we're going to do here is we're going to pass in a dynamic value, and this is going to be the user name here. So instead of passing in this data, I'm just going to go ahead and we'll go ahead and throw in the username here, and then we'll render that out. So we have 2 more views. Let's go ahead and create the URLs for these. And this is going to be in our apps URLs file. And in here, we're going to create the path function. Again, it takes in a route. So this is going to be users, and then the endpoint itself will be user_list. And Francesco, let me know once I start passing that time. So views.userList, and then we'll do path users, and then we'll just pass in the dynamic value. With this, we use these angle brackets. We're going to set that as a string value, and then we give it the name of user name here. So like that. And there we go. And then we also have to add the corresponding view to this. So we'll do views.users detail or user detail. Okay, so we have these routes. We have most of what we need configured. So to test this out, let's say we want to go to see all our users. We'll just do users like that. Okay, so we see the array of users. And then if I want to see a specific user, let's just do Max for the username. Now we see Max's information, then we can see the thus, and so on. So now we have that route. And I know it might be a little bit harder to see here, but we have this route where we can pass in that dynamic data. So I hope that's all making sense. We just created those 3 endpoints, one that tells us about our endpoints, and then one for our users list, and another for user details. Now, we also have the Django REST framework. There's awesome documentation on it. And what we're going to need to do is go ahead and run an install. And it's going to be a wrapper that basically gives us a lot more functionality here. So let's go ahead and build that out here. So we're just going to go ahead and run a quick pip install. And at this point, I'm actually going to open up the terminal within VS Code here. Give me 1 second. For some reason, it's not wanting to listen here. Bear with me. There we go. Okay, for some reason, it's like open full screen here. So we'll open up another terminal, and we're just going to do pip install Django REST framework as one word. Okay, so that should be good. So I already have it installed, so it's going to go ahead and tell me all those all those requirements are met. And in order to actually use the Django REST framework, we're just going to go ahead and go into our settings.py file, so that core configuration, and we need to let Django know about this package that we just added, so REST framework. Okay, so we have the REST framework, and to actually use this, first of all, what we're going to do is go ahead and import a few things here. So we're just going to go ahead and import a decorator. So from rest_framework.decorators, we're just going to import the API _view decorator. So we can use class-based views and function-based views, but we're going to stick to function-based views on this one. So class-based views are basically views written as classes instead of functions. So we also need to import from REST framework.response, and we're going to use the response object from the Django REST framework instead of this JSON response. So this is a little bit limited. It just takes our data and it kind of turns it into JSON data, but it can't handle Python classes specifically. So all we need to do is go ahead and add in this decorator here, so API _view, and this is going to take in a list of methods that we can actually send to this endpoint. So at this point, we're just going to go ahead and pass in a GET request, but if we want to allow a PUT request, maybe a POST request, we can also do that. So at this point, we're only allowing a GET request. We're going to build an API that only provides data as opposed to allowing some kind of interactivity with it. So once we do that, then we can use this response object. So we're just going to go ahead and change that to response, and then we can remove false here. And you're about to see the functionality that this gives us here. So let's go ahead and just paste this over these two. Let's go ahead and take response. We're just going to do a little copying and pasting now. Paste that over, and then we're going to get rid of safe here. Okay, so with that, go ahead and open up our website. So if we go to the home page, you're going to automatically see this interactive UI here. So this is what the Django REST framework does for us. It gives us a little bit more information about that response that we have. And it also gives us a way to interact with this. So at this point, we're only allowing get data. So right here, we only see a get request, but if we allowed post, it would actually give us a form to interact with it. It just makes our API a little bit more user-friendly. If we want to see this as raw data, all we have to do is click that, or just add format equals JSON, and we're still going to get data in this specific format. So if we go to our users, once I get that set up here, there we go. So we're seeing this data. So it gives us a little bit of it beautifies the data, I guess, if that's a word. It makes it a little bit prettier and easier to understand and work with. So with that, now it's time to get to more of a practical API. Is we want to build a database object, and we're just going to go ahead and build out a model. Django already has an SQLite database built in by default. You can change this to a Postgres database or a MySQL database. That's up to you, but it already comes with it, so it makes this process very easy. So we're going to create a class, and we're going to call this one advocate. We're going to create our first advocate. Essentially, we're going to create a class that represents a database object that will be turned into a database table. And then we're just going to go ahead and actually query this database and then render this data out in the API. So it's a little bit more practical. So we're going to want to go ahead and pass in, let's say, a username. We'll start with that. And then we'll just go ahead and set the value or the type of field that this will be. So this will be models.char field. So it's just going to be a character field. So that means it's just going to be a text field. And we do need to set the max length that this field can be. So we'll set that at 200 characters, and then we'll just do something like bio. So we'll only add 2 fields here. So then we'll do models.text field, and text field, we want to make sure that this is not required. So I want to be able to keep this field empty. And then we also want to make sure that we can submit a form without needing anything in this specific value. So that is our database model. So again, this will be a database table called advocates. It's going to have a column called users and a column called bio. So in order to actually work with this data, we need to run a migration real quick. So we start with Python manage.py, make migrations. So what this is going to do is it's going to go ahead and prep some commands that are going to be basically like SQL commands that are going to actually inject into the database and make that table in the database. So once we prep that, we need to run that migration. So Python manage.py migrate. So we ran that migration, and now we can start working with this data. Francesco, how am I doing on time? It seems like I'm going a little bit over.
You're doing great. Just all to no. If you are finishing, it's great. Dennis, please go on. Keep finishing and collecting the questions.
Give me a few more minutes here. Yeah, 1 second. So once we have that, I want to add some data. Then I just want to render it. So we won't do search. We'll just go ahead and render the actual data. So one of the things here is we do have a built-in user model with Django. So we create this user, super user. We do have to create a user. 1 second. Create super user. So we're going to create a user. I'm just going to go ahead and give this a name, Dennis, and then dennis@email.com. Obviously a fake email. And then I'm going to have to double type in this password. It's not going to show as I'm typing it. And we're just going to have to run into the admin panel that Django gives us. And we're going to add the data and then render it. So again, Francesco, let me know if anything. I'll try to do this within 5 minutes here.
This is super interesting, to be honest. Yeah, please finish
okay,
this and
awesome.
then just stop whenever you can. But
sure. Sounds good. Okay, so I have to go into the admin panel and just register this new model that we created with the admin panel so I can actually see it, and you'll see what the admin panel looks like. Basically, Django gives us this interface to work with the data. So all we have to do is register it. And once we have that and we created our database user, we can actually go into our admin panel, which starts with localhost 8000 and then /admin. So we get this interface, and we're just going to go ahead and log in with the user I created. So we'll try to zoom in here. So let's see if my password is right. There we go. So here we have this admin panel. So it's this complete interactive UI that we get, and we're just going to go ahead and add these users. So we'll do add advocate. We'll just do todas for the username. For the bio, let's just leave it blank. Actually, let's actually do some lorem ipsum. So real quick. So it shows. We'll get some dummy text in there. Okay, so we'll just add another user. We'll do 2 here. So we'll just do Dennis, and that's it. And then add a bio. Okay, so for the part, my favorite part here, here's where we actually render this data and where the Django REST framework gives us this functionality. So we need to serialize this data. So in order to render it out, we can't just render out a query set. So for example, to query the data, we'll just do from models import advocate. So in order to render this out in the view, we would be able to do something like advocates, and then we'll just set that to advocate.object. So Django has its own ORM, so .all. So this is how we would actually query that data. Now, in order to actually render this data out here, we can't just do that. So if I actually try this real quick, I want to show you the issue and then we'll fix it. We'll close this out. If I try to render this out, we're going to see this error that basically says we can't serialize a Python class. This is a Python object, and the response method can't render that out. So we need to serialize this data first. So what we're going to do here is we're just going to go ahead and create a serializer. And I'm going to do this right within the view. Typically, I would create this in its own file. But from here, let's just do from REST framework .serializers import model serializer. So essentially, this is going to be a Python class that's going to take my model here and turn it into a JSON object. So it's going to take care of that process. So we're going to create a class called advocate serializer. And then we're going to pass in model serializer to that. And then we just need to pass in 2 parameters at a minimum. So we'll pass in the model field. So what model do we want to serialize? That's going to be the advocate model. And what fields do we want to render? In this case, we're just going to do all. So we want to serialize both the bio and the name. So once we do that, all we need to do is go into our advocates. We need to use this serializer. So serializer. Always have a hard time spelling that. And then we'll use the advocate serializer. So all we're going to do is go ahead and pass in advocates. And then we need to pass in many is equal to true. So this means that we want to serialize multiple objects here. So if we want to do false, that's going to return back an object. If we do true, that's going to return back an array of objects. So now we can take this serializer and then pass in that into the response with the data attribute. And let's go ahead and render this out. If that works, I hope at least this works for the demo. The advocate is not defined. Give me a second here. So from, I thought I already imported this. Import advocate. Right, I did that as fast as I could with explaining as much as I can. So this is our database object, and we just serialize that. We see the ID. Django creates IDs for us by default. We see a username and a bio. Well, we haven't done that for the specific advocate page, but that is how we're able to get a real database, serialize that data, and render it out and provide an API. And now I would send this to some kind of front-end developer once it's live and say, hey, work with this data, make request to the endpoint of /users, and that's it. So Francesco, 33 minutes. Well, I guess we talked more before that. But
Dennis, Dennis, to be honest, I'm speechless because you almost nailed it live. You basically made a Django crash course live. So congratulations for real. It has been really amazing. And yes, so we have to skip the questions, but I'm saving them. So maybe we can. I think Dennis will be in the chat if you want.
Yes.
So you can keep asking him stuff. But Dennis, this has been an incredible streams, and I've also learned a lot because I've also used Django in the past. So I learned this live. So thank you so much, Dennis. But we have to go with the next speaker. If you are still here at the end, if you have 5 minutes, we can also keep getting some questions. So if you have some questions for Dennis, please wait for the end.
I'll be here.
Thank you so much. Thank you so much, Dennis. Really. Let me remove this. And let me invite Sabrina. So Sabrina, welcome. I'm super happy to have you here. And Sabrina is a developer advocate at Shakudo, right?
Yeah. Hey, Francesco. So happy to be here. I'm great. I'm so excited. I'm going to talk about a lot of cool stuff as well. Dennis totally nailed it. I'm super impressed. It was like a YouTube video, right? So super cool.
It's harder to go after Dennis, I know.
Yeah, totally. Yes, but I'm going to talk about a lot of cool stuff as well. I'm pretty excited.
Absolutely. So I'm super happy. I really wish you best luck, Sabrina, and I'll be in the backstage. And if you have any questions for Sabrina, just drop them in the chat. Good luck, Sabrina. Bye-bye.
Thank you so much, Francesco.
Bye.
Hi,
Bye.
everyone. It's great to be here. I am Sabrina, and I'm a developer advocate at Shakudo, and I'm also a computer engineering student. And right now, I live in Brazil, and I'm going to go teach you guys how you can abstract backend complexity. So the title of the talk is actually how to build, train, and scale a machine learning model in 25 minutes using Shakudo, which is we're going to do that. But I want to focus a little bit more on how you can abstract all the backend complexity while you're doing that. So I'm going to actually go through the process. Machine learning developers or machine learning engineers and data scientists usually go through create a machine learning model to create a machine learning process, and how we can actually abstract away much of the things we're done. So usually it goes a couple of different ways when you're building a machine learning pipeline or data pipeline, right? So first we have the machine learning scientist or data scientist. And he has a few jobs, but the main job he has is to build cool machine learning models. This is actually what this is about, right? But usually the job doesn't end there. The machine learning scientists usually also have to take care of the ETL of the data, which means he has to find a way to extract, transform, and load the data into the application. He also has to deal with debugging version conflicts. So this can be a pretty bad one, along with setup the development. I'm always talking about that. Setup in development can also take a lot of time, can also be a bit annoying. Also, he has to refactor the proof of concepts to production code. So the proof of concept is that code you do to prove that your machine model actually is going to work and is going to bring results to the business. And after he does that, he actually has to make it to production code itself. After that, he's going to have to build connections for the data to flow into the application and to the pipelines, make plots and reports to demo. Also set up model checkpoints for running jobs. So it's a lot of stuff the machine learning scientist has to do when actually building his side of the process, his side of the work. After that, it doesn't end there to build a machine learning model. After that, it goes to the machine learning engineer or to the DevOps person. So the job here for the DevOps person, after he receives this machine learning model, if you're just working with data, it doesn't have to be a machine learning model, is to build the cool products, actually put them to production after they receive the code, right? So, but it doesn't end there for them as well. Sometimes they need to understand and refactor the code they receive, right? So they also have to write tests and modules for interference pipelines. So when they want to put the data back into the model, they can do it easily, but they have to build the whole thing by themselves. They also have to package environment and code. Sometimes they even have to rebuild it in different frameworks, fit the code to an existing pipeline they already have, so they have to figure out a way to do that. Besides all the monitor and maintaining of the project, right? So they have to all the time be there monitoring and maintaining and getting notifications of what's going on. And they have to do it all by themselves along with debugging. So obviously this is a lot, especially for those of you who are just beginning to working with data and perhaps getting into machine learning. It's a lot for you to handle at first. So you probably get stuck in not creating such much complicated models, right? So you usually don't work with large sets of data. Usually you can make a huge impact, not necessarily, but usually you can go too big into the training that you're creating. And what we find is that it becomes so hard to create nice products when you have so much bureaucracy around it, right? So you need a lot of engineers to do that. You need a lot of cloud costs. It costs a lot for you to do that, right? And for you to have a node available for you to do all of these interferences in pipelines. So what we're trying to do here, and what we thought it would be a nice idea, is all Shakudo is about, is abstracting away everything that is not building cool models or building cool products with the models. So we make it as a way that you don't have to worry It seems quite impossible, but really, you don't have to worry about any of this other stuff. And you just build your machine learning model, you just create your code, and then you just deploy it to production with a few clicks, which I think is super cool. I'm going to show you guys how to do that. So right now, it's a 3-step process. So you go to the Shakudo platform. This is what the home look like. So you're going to want to start a session to do that. This is basically spinning up a node for you to work on, spinning up your development environments for you to work on. After you do that, you create the type you want. You can use a basic image if you want. You can use a deep learning image. If you need GPUs, you can use that as well. This is a basic one I'm going to need, so I'm just going to set it to basic. Timeout is a time for the node to run off if you're not doing any activity on it. So if I'm away from the tab for 15 minutes, just shut it down so I can save on cloud costs, and it's not just running there if I accidentally forget to shut it down. So I'm going to set to 15 minutes, and I can choose the drive, which I'm going to run it as well. I'm just going to leave it like that because I already have a session running. So this is my session. And you can just go here and open a new tab with your session. So what this does is this creates your environment for you to start your code. Right now it's a Jupyter Lab, but usually if you are not creating a machine learning model, which is usually what people do with data scientists like to use, you can also make an SSH connection and connect the platform to your VS Code, and you can actually do the whole repository inside your VS Code and just push the code to Git once you're done using it. So yeah, so this is a 3-step process we're going to do here for the whole train, scale, and deploy. And first, we're going to get the data preparation. Okay, so we're going to start by preparing the data. And now we're going to grab an input data. So it's the train data, it's raw data that we're going to train. And we're going to get the clean data out. So this first step is just processing the data so we can get started with the training. Okay, so let's get started. The first thing we're going to do here is we're going to want to use Dask. So if you're not working with huge amounts of data, you might not want to do this. But if you're working with large amounts of data, right now we're trying to process around 11.2 gigabytes of data. This is a lot of data. If you're doing that, you're probably going to want to use distributed computing. And Dask is a great way for you to do that. So Dask is basically a library, a Python library for parallel computing. And it makes your Python code multi-core. So it can run on multi-core local machines or large distributed clusters in the cloud. It makes it takes a big chunk of data and creates smaller chunks of data out of it. So you can process it in parallel, so your code runs much faster. So what we're doing here is we need to set up the Dask cluster before we start our computation, right? So we import all the files, and we're going to start spinning up the cluster so we can start distributed computing. Using the hyperplane, you can do that just by importing this library. And in one line of code, you can already initialize your cluster. So you already have your cluster running right here. So your cluster runs along with your code. Once your code starts running, your cluster is open, and then you start your processment of data. So here we're processing around 2.4 gigs of data, and it's taking about 6.16 seconds to do, which is pretty crazy. It's a super fast way to get your data processed. And right after that, we're closing the Dask cluster. That means the Dask cluster was only up for those almost 7 seconds while we were processing the data. And after that, we close the cluster. And so this is what we're paying for, basically. We're just paying for all those 7 seconds the cluster was up. And after that, we're going to train our clean data, right? So we're going to train over 6 giga of data with Dask. So we're going to initiate the cluster once more, one line of code, and then we're going to start training the model. So to train this a data set of this size, it takes probably 6 gigabytes. It takes around 2 hours in a best day or so. So it's going to probably be a little more than that. So the more features you add to your data set or your training model, the wider it gets, the more time it will take to train. This right here has around 510 features. So it actually would take more than a few hours, maybe 3-4 hours to train in the best day if you're not using distributed computing. So you can also, if you click on this link right here, it will take you to the desk cluster image where you can actually see the desk cluster in action live. And you can see the data being processed by the workers on time. So the first time you can see each worker and the load in each worker of your node. And you can see them working alongside each other and see when your data gets prepared, which works super quickly, by the way. So, okay, so we're going to train the model. To train the model, we're just going to use this code here, and we can see that the time it takes for us to do that is 1 minute, 8 seconds. So what usually used to take, I don't know, like a few hours to do, right now we can do like in 1 minute, 8 seconds using Dask, which is super cool. And it's super, it saves up a lot of processing time, a lot of time actually just waiting, time that you can actually do anything other than that, just run that code, and it's running on the cloud, consuming costs and infrastructure, needing infrastructure management. And cool, yeah. So after that, we save the model to the cloud, and here we can see the estimate feature importance. So I mentioned we had around 510 features, different features. And in this part right here of the code, we're estimating which one of those features are actually making a difference for our model, which one are actually more important for me to get an accurate result, which one of them is not. And so I can get an idea of what's actually working. And after that, I can just shut down the cluster. So if you actually take up all this time it takes for the cluster to do that, you can see that usually it's going to probably take around 1 minute, 30 seconds for us to do all that just with the cluster up, and then we can shut it down. And after that, we can go to the inference part. So for those of you who don't know what inference is, it's basically actually when you want to infer more data into your code so you can train it and get other results with new sets of data, just adding to what you currently have. So in here, we're going to show how this process works. So we're trying to interfere 3.5 gigas of data to the set we already have. So we're gonna start by, again, we're just gonna start by setting up the desk cluster. So in this desk cluster, we can actually see that after that, it becomes much more clear and faster, everything we're gonna do after that. So basically what we're trying to do here repeatedly is like, okay, we're done with this part. We can do some code, data science code, machine learning code, or even if you're not doing machine learning, you can just do data processing and data cleaning, or just ETL processes. And we're opening this cluster, doing what we need to do, and then we're closing it. So we're saving a lot of time while we're doing that. And after that, all we need to do is, okay, now I need to figure it out a way to run all of these codes separately, not separately, sorry, alongside each other at once, right? And whenever I want them to run. So this is where you begin to need jobs for your data environment. You're going to need this to be in a pipeline. So you can actually do a YAML file. So if you guys don't know what a YAML file is, it's basically a recipe. And what it's telling us is, okay, so start by this path, run this code, and then you can run this code in step 2, and then run this code. And every time I run this file, is going to run this piece of code, and then this piece of code, and then this piece of code. And then we can actually create this job who's running all of these data preparation and training inference anytime we want. All we need to know now, all we need to do now is go to the YAML file and copy the path. And now we're going to the deployment part. So actually putting the code into production and making it run and seeing how it runs live. So we're just going to start a new job and just go to the jobs tab. You can create a scheduled job if you want to. So if you want this job to run every 10 minutes or every hour or every day, you can just go here and you can set up the time. If you don't want to, you just want to create an immediate job, you can go here, set up your job, and everything you need to do is just paste the YAML path without the Git repo. And that's it. That's basically what you're creating here. So you can also do version control. So after you prepared your whole code here, what you're going to want to do is push everything to Git, commit everything to Git, so you're up to date with the version that the backend of the platform is also working with. So once you go here and create your job, the job knows exactly what file is on that branch that you're mentioning. If you're on the main, that's the basic default one. Just leave it like that. If you have a specific branch that you want to run or that your file is at, just put that and you can just create your job right there. So we can see here, our job is already pending. If we keep refreshing, okay, it's in progress. And like we saw, the whole process, actually, the interference part took about 1 minute to do. And this is super fast for this amount of data. So what we're actually trying to do here is running all of these separate piece of codes in these clusters who are appearing and disappearing super fast and are actually saving us a lot of money by doing so. So what usually happens in other platforms is that you usually have your node. It is a super powerful node who's live every single time. And every time you need to run a job, you just connect to it. And that's basically it. You need to pay for the whole time the node's up. And here, what you're doing is that you're making your node go live just for when you need to create it. So if I need to do a job now, I'm gonna just set this node live for a few seconds and then close it up. So after that, we can already see that in a few seconds it's going to be done. And these other projects, these other jobs, is all the jobs who are currently running in the Shakudo platform, in this cluster at least, who usually is done in very small amounts of time because of the distributed computing. So this is a very cool part of it. And going back to here, we can see okay, I was talking about the jobs parts and how you can do it with just one line of code. And when you put this line of code there, you can already deploy it. And your code is literally already deployed and ready to production. If you want, you can, okay, I don't want to run it on the platform. I want to run it on my own code. You can copy this mutation query. This is a GraphQL you can add to your code if you want, for example, to make this job run every time you click a button on your front-end application. So you can also do that. And this is really cool. So in the end, what we have here is that we could do all data preparation, training, inference, and also the deployment. If you take we creating a job and actually deploying it to be 1 minute or so, we can actually do it in 4 minutes with the platform. Of course, not counting all time it took for us to write the actual code, which is actually not very complicated once you're actually a data science working on it. It's actually the fun part, the cool part, like we were talking about. The bad part is the one, and the part who takes the most time is this one that we just created. And it took us just 4 minutes, and we already have it to production. We literally just abstracted away all of these other parts of the job that we mentioned previously. We don't need to do that anymore. And it's super cool. We also have in the platform integrations with, okay, so, but I'm using, I don't know, Airflow. Can I redirect my workflow to Airflow, for example, and kind of use it alongside Shakudo? I have some jobs on Airflow, and I'm figuring out I can use them both alongside each other. You can also do that. Many other backend tools, you can just add them, like Snowflake, for example, and actually blockchains as well. So we're kind of in this, all data is data, and we're creating this kind of making it easier for people to get access to blockchain data. Because right now, the way that the blockchain is divided is that it is in transactions, right? The blockchain is divided in chunks of transactions, and it's quite hard to read. So we make it easier, giving you nodes actually to connect to the blockchain, translating that into APIs, who you can actually use all the blockchain data like a usual API for your database or for your code, which is super cool as well. And yeah, that's mostly what I had to say. And this is how you can actually abstract away a lot of the backend complexity. Sometimes you don't even realize how much you're doing with all of these stuff, but all the work that goes behind that to deploy this pipeline, if you're not using this, is actually, it's huge. Okay, Francesco, you're there with me.
Amazing, Sabrina. Congratulations. Is this one of your first talks or not?
Yes, this is my first live stream.
Mind blowing. Way better than me for sure. So it has been it has been really amazing. I learned a lot. Thank you. And I have also some questions, to be honest, but let's take the one from the audience first. But first of all, let's get your deserved congratulations if they jump in the software here. And yes, we have some questions here. Please remember next time on the thank you, remember to add your connections, like your Twitter handle, other stuff. That's the nice the nice trick, of course. So
that's it. I'm not gonna. Yeah, this is
exactly
this is better.
Exactly. So you put them also at the end because they're nice. Perfect. Let's keep this one. Okay. So we have some questions that I don't know if they are related to just what you did or to machine learning in general. So feel free to say if we can reply to some of them or not.
Amazing.
So Srinivas is asking about the model size and how does the inference adds up on the existing model?
How does the inference? Sorry, I didn't quite get that.
Yeah, I don't know if you can read because in the live stream I highlight the question. They ask what's the model size and does inference adds up on the existing model?
Right. So no, the inference is data that we add to the model after we already have prepared all the initial data and trained it. So the model size is actually 11.2 gigabytes of data. So we're processing it and we're training around 6 gigabytes of that data. So yeah, and the inference is 3.5 gigabytes.
Nice. And other one about Srinivas, which is very interested in today's live stream. And if you want to drop a question, drop it now. Otherwise, I'll make my own question. So this is your your chance. Do you have to train the model again if a new user comes in? Srinivas, can you hear me?
Yeah, I'm sorry. I'm trying to find this question.
No, I'm highlighting. Can you see them? Are they in the chat in the event? Can you see? It's the one with I'm highlighting here. No, Srinivas.
Oh, so sorry.
No, can you see in the screen? It's on your screen, Srinivas.
Can you repeat the
question? Sure. Do I have to train the model again if a new user comes in?
Right. So you don't have to train the model every time. So you just train the model once, and you can train it again if you have like these new large sets of data you need to, okay, this might change eventually. But usually you just train the model a few times. It's one time, and then you can just do inference of new data if you need to.
Perfect. And so now I have here the congratulations for the talk. And I only have one question about let's keep the blockchain away, otherwise this will last for more hours. But about the Grafana integration, because I'm also a huge fan of Grafana, and yeah. I know that that's very powerful. So since I see that there is an Grafana integration, Grafana is basically a tool to display dashboard, and it's super powerful.
Exactly.
So if you have Grafana logs, you can basically have very nice looking dashboards. And this was also unscripted, the question. So I see that she's doing stuff, and yeah, this is the Grafana integration, and this looks very cool. It looks
so
very cool.
In Grafana, you can use this to debug everything you have in production. So if something comes up and you have a mistake in your code and you're just not running, you don't know why, you can just go here on Grafana and check everything that's going on, all logs, everything like that. If you also want to do some BI, for example, you can go to Superset. Superset is a great tool for BI, and you can just click it on the Shakudo platform and go redirect itself to the BI and all the graphics of your application, machine learning, or data projects as well, which is super cool.
Nice.
So here we can see the jobs, the logs for the jobs we're just talking about.
Amazing. Also, Srinivas is saying thank you because you're replying to a couple of questions. So thank you so much, Sabrina. This has been really amazing. You did an amazing job. So let me invite the last speaker. And if you're still here at the end, we'll also invite you again.
Amazing. Excited for it. Thank you, Francesco. See you guys. Thank you, everyone.
Yes. Okay, let me invite Simon. Simon, last but not least, super happy. Finally, we meet. Simon is a developer advocate at Platformatic DB, right? I think it's a kind of new. Yeah, I don't know if it's kind of new, but like
just over a month old.
Nice, exactly. So, Simon, a short introduction about you. We have been connected because of Matteo Collina, which is our dear friend, Italian friend, and yes. So, something. Can you please introduce yourself and then share your screen, and then we start with this last talk.
Perfect. Thanks so much for having me, Francesco. It's great to be here. And so I'm developer advocate at Platformatic, and I do a lot of development with Node.js. I've been coding for over 20 years. I think I'm kind of ready to jump straight into it and share with you kind of what the team have been building on Platformatic DB and what everyone can do with that today.
Yes, perfect. So you can start sharing your screen. In the meanwhile, hey Danny, how's it going? It's always a pleasure to see you here. Srinivas, and also, perfect. Nice. Okay, so Simon, we have some time. I like the title, Adventure. I don't know, it's a very good title. And yes, so good luck and see you in around 20 minutes. We are in time, so take your time.
Thank
you. Bye.
Thanks. Hey everyone. So a little bit about me before I start. So I'm an independent Node.js consultant and educator. As I mentioned a moment ago, I've been coding for over 20 years. It gets longer every time I say it. And I love helping developers learn. So over the past couple of years, I've been writing a lot of blog posts and running different workshops and doing a lot to help developers learn new skills, especially around Node.js. I'm also an Egghead instructor, and I'm working on my first course for Egghead, which will teach you how to build a Node.js API with the Fastify web framework. Lastly, you can find everything on my blog at simonplen.com, and you can drop me a message on Twitter or find me over on GitHub. And that's all about me. And let's take a look about where we're headed today. So there's plenty to pack in. We're first going to take a look at how we build an API, what it takes to build an API, how Platformatic DB can help us with that, and then how we can we'll do some live coding and learn how we can create an API with Platformatic DB. And then we'll explore adding custom functionality to that and how that allows us to have lots of flexibility. So let's jump straight in. So what does it take to build an API? Typically, if we come to build an API, we'll sit down and we'll need to think about our API interface. So if it's a REST API, we'll be thinking about the different endpoints and what HTTP methods we'll be using. For example, what names we'll have for the different endpoints. If it's GraphQL, we'll need to think about the schema, what kind of queries we want to support, what kind of mutations. And then we need to decide on a database system. So will we use SQLite or Postgres or MySQL or any of the other database systems that are available today? So then we also need to go and think about designing and creating our database schemas. So what tables we want, what names they're going to have, what fields, all the different decisions we need to make around our database. Then once we've done all of that, we need to go and integrate a database library. So we need to choose one first, find the library that looks best for the database system that we're using. And then we're going to want to go and wire up all those RESTful endpoints to create, retrieve, update, and delete the data. And we might have to do that lots of times, depending on how many different types of data we're storing. And we also want to do this for GraphQL as well. And then we want to add request validation to all our API endpoints to make sure that we don't end up with incorrect data in our database and that our API is nice and secure. We're going to also want to go and document the API so that when we come back to it in the future, we know how it works, but also if we're working in a team or we have other people using our API so that they understand how the API works, how they can make requests to it, and also what kind of responses they'll get back. And there's a whole lot more. This is just kind of scratching the surface about what it takes to build an API. It's a lot. And if you're building APIs frequently, it becomes kind of repetitive work, like doing these same steps again and again. They're really important foundations of building an API, but it can be quite time consuming. So this is where Platformatic DB comes in. And as I mentioned earlier, it launched just over a month ago now. And it's an open source HTTP server that's built with Node.js. And it provides flexible tools for rapid development. So it allows you to actually take your database and then map REST and GraphQL schemas on top automatically. So you can see over here in this diagram, we've got, for example, you might have a front-end application, and then you could have a Platformatic DB API that is presenting a REST API and a GraphQL API. And inside of that, Platformatic DB is using an SQL mapper to map all the different tables and all the different fields that are in your database and expose them through the REST and GraphQL interfaces. You'll notice that there's also your code. That's an option too, but we'll look at that in a little bit. So Platformatic DB is currently in public beta. And if you want to try it out, you can head over to oss.platformatic.dev. We've got a quick start guide. We've got a big tutorial there where you can learn how to build a full-blown application along with an Astro front end as well. And there's also plenty of reference documentation too. So just to quickly run through a few features that we have in Platformatic DB, and then we'll actually jump into some live coding. So there's a command line interface. So I said it was an HTTP server, but it's a little bit more. So we have Platformatic DB, and this command has other commands underneath it, and we'll see those shortly. But they allow us to start up a server running, to run migrations, or to export, for example, the OpenAPI or GraphQL schema from our API. And Platformatic DB supports SQLite, PostgreSQL, MySQL, and MariaDB. There's also built-in support for database migrations, and we'll want to write those when we're creating new tables or adding new fields into our database. And also we can handle seeding with Platformatic DB, which allows us to populate our database with data if we need to set it up with some data when we start building our application. So it also exposes a REST and OpenAPI API for us. So we get an automatic REST API from our database schema. And we'll see what that looks like, alongside some interactive documentation through the Swagger UI, which allows people to understand how the API is working. And all of this is built on top of an OpenAPI 3.0 schema. And this allows us to actually then add this schema with other tools, and it improves the interoperability that we have. We've also got GraphQL support as well. So as well as REST, we can have an automatic GraphQL API from the database schema. And we have full support for Apollo Federation. And bundling along with that is the GraphQL web-based GraphQL IDE, which allows us to run GraphQL queries from our browser and test out and work with our GraphQL API. And we can also export a generated GraphQL schema from Platformatic DB. So we can actually then go and use it with other, for example, code generation tools, which allow us maybe to generate types for our type if we're doing a TypeScript front end, for example. Also, there's authentication and authorization. So we support JWT, webhook, or HTTP headers in dev only as integration methods with other authentication services. And then there's authorization baked into the REST and GraphQL APIs so that we can actually build applications where we restrict, based on a user role, what things people can do, what they can write to, what they can read, what they can delete, for example. Okay, so that's enough slides for now. Let's take a look at some code. We're going to head over into VS Code here, and I've installed Platformatic already. We've got it here as a dependency. And if I pop this up here, we can then run that Platformatic CLI with npx Platformatic. And it shows us the commands that are available for us. So now what we're going to do is actually set up our application, and we're going to run it with npx Platformatic DB init. And this is going to go ahead and create several different files for us. So we'll see we've now got this migrations directory, and we've also got a Platformatic DB.json. We'll explore those in just a moment, but first of all, we're going to copy over these dependencies that are here and install them. So let's just give myself a bit more space. And so we'll copy this line here and paste that in. And now, while those dependencies are installing, we're going to go and take a look at the migrations we've got over here. So I mentioned earlier that migration support's automatically built in. So when we ran that init command, it created this SQL file, which creates a database table movies. So this is regular SQL. There's nothing special about this. There's no extra layer on top. It's raw SQL, and it allows us to create a database table. We've also got an undo migration if for whatever reason we wanted to roll back, and that will drop the movies database table for us. Now, the key part for Platformatic DB is that everything lives in this Platformatic DB.json when you get started. So it specifies some settings around the server, what host name it should listen on, what port, and importantly, what the connection string is for the database. Now, by default, it's going to set up an SQLite database for us, but you can set this up to connect to Postgres or MySQL or any of the other supported databases. And then we've got migrations over here, which is that migrations directory. So it knows or tells Platformatic DB where to find the migration files. And we've also got types being auto-generated for us as well. And we'll see what that looks like shortly. So now if we go ahead and actually run npx Platformatic DB migrate, it will go and apply that migration for us. So it's run that 001 do.sql, and because because SQLite is a file-based database, it's created that file db.sqlite for us. So now that we've got that actually all set up, we can go ahead and start our server with npx Platformatic DB start. And now our server's listing. So we can click on this URL and open it up in our browser. And this is the welcome page for Platformatic DB. Now we can actually go ahead and look at that documentation I mentioned earlier. And this is the interactive Swagger UI. So it shows all the endpoints that are available on our API. In this case, we're going to give a try of the post movies API route. So we click here to try it out. We're going to add the classic movie, The Wizard of Oz. Okay, so if we now scroll down and then execute that, it's made a request to our REST API, our Platformatic DB REST API. And if we were to run it with curl, this is what the request would look like. So it's posted through this data, and then it's got this response come back. So it's actually created that now in our API. And we can head back over to our terminal here in VS Code, and we can actually go and curl that. And so curl is a command line tool which allows us to make requests to different HTTP servers. In this case, we're going to request our local one, which we've just set up with Platformatic. And we can see there that making a GET request for all those movies is bringing back that response with that movie that we just created. Now, to make things a little bit more interesting, we're going to go ahead and actually add another database table. So we'll stop our server, and I've created a few snippets over here just to make this a little bit quicker today. So we'll close these migrations, and over in our migrations folder here, we're going to create a new 002.do.sql. So we just put them all in a sequence in the order that they need to be applied. So we need to create an undo, and that will be the down operation if we want to roll back. So let me just grab from the snippet. I'm going to grab this table here to create a new table, quotes, and then this is the down migration, so the rollback. So we've got a migration now, which is going to go ahead and create a quotes table. So we want to store some movie quotes, like famous movie quotes, and in a moment we're going to add one for the Wizard of Oz. So now we've got that there, we can go ahead and run npx platformatic db start. And that will start our server back up. Note that we didn't have to run a migration command, it automatically ran it for us, and that's configurable through the configuration. So now if we head back into our browser and refresh, we'll see that we've got all the movies and quotes here. So all that has been automatically mapped from our database by Platformatic DB. Now, if we want to try something else out, we're going to jump in and have a look at GraphQL, and we're going to use this to actually call the GraphQL API that's been made available by Platformatic DB. So we can actually see here, if we click here in the docs on the side, we can see what queries are available to get back the movies and the quotes that are there in our database. And we can also then go ahead and make some queries. So again, I prepared a couple of queries here so we can get things up and running. So here's a query to get all the quotes back. Now we're going to run this query, and we'll see that there are no quotes right now. So we've got movies we've got that movie, that Wizard of Oz movie in our database, but we don't have quotes. Now, what we want to do is go ahead and actually create a quote. So I'm going to grab this query here. And this is a mutation. And this mutation in GraphQL allows us to actually go and call this save quote mutation, which is automatically created by Platformatic DB and made available. And then we can actually say, pass through. So this is our movie ID 1, which is our Wizard of Oz movie. And here's the quote we're going to pass through, and then the said by field. So who said it? Dorothy said this quote in the film. So we'll send this, and these are the fields that we want the API to return back to us when we run that create quote. So let's run that mutation. And now we can see that that's been saved for us. Here's the ID for it. And the neat thing here is that when we've saved that quote, we can also get back the movie data. And that's because over here in our actual migration that we created, we've got that movie ID field. So it references that. So the quotes field references the movies table, and Platformatic DB automatically understands that. And when it creates a GraphQL API for us, it automatically maps it so that we can then pull back nested data, which is pretty neat. So now we have that all up and running. We're going to go back here just to show that it's working with our REST API. So we're now going to make a request to the quotes endpoint. So this is a GET request. And it's saying, we can see that full quote data coming back through the REST API. So it's the same database, but two different interfaces, the GraphQL one and the REST one. So far, we've got quite a lot of functionality up and running. And out of the box, we've got lots of features. So that's pretty great. But the best part is what comes next. So what about custom functionality? At some point, we're going to probably outgrow the automatically mapped REST API and GraphQL API. And we'll want to add our own custom functionality, such as custom REST API routes or GraphQL queries and mutations. We might want to use other packages from NPM or use built-in Node.js modules. We really want to have full flexibility so that we're not kind of locked in to the base features that Platformatic DB provides. Well, the good news is that we can actually build on top of the Platformatic DB foundations. So we've got that REST API and that GraphQL API. We've got migrations. We've got authorization in there as well. But we can actually access the things that Platformatic DB is built on. And one of them is the Fastify web framework, which is a fully featured web framework. And we can actually access everything that's provided by that through Platformatic DB, as well as Mercurius, which is an adapter for Fastify. It's a GraphQL adapter, and that's what powers all the GraphQL part of the API. Underneath Platformatic DB is also the @databases library, and this library provides SQL adapter, and it actually provides an SQL query builder. So we've got all these things which Platformatic DB is built on. They're running under the hood with what we've just seen, but actually we can access them ourselves to build our own custom functionality. So this means with Platformatic DB, you can choose your own API adventure. It means you can go ahead and create custom REST API routes or GraphQL queries and mutations. And it means we can use the Platformatic SQL mapper. So that's the thing that under the hood in Platformatic DB is doing all that mapping from our database through to the entities that are then represented by the REST or the GraphQL API. We can also, if we want to, write raw SQL queries. And we can also even go beyond that and use the Platformatic packages standalone. So we don't even have to use Platformatic DB. The packages that are available, that have been created as part of Platformatic, allow us to actually go and build our own custom applications outside of Platformatic DB. So this really allows us to choose the level of our abstraction and where we want to kind of focus our energy. So another demo time. So we're going to jump back to our API here and let's tidy up what we've got here. And we're going to go ahead and add another migration. So for this migration, we're going to, you guessed it, add 003 do.sql. And we're going to add another one to undo. And let's just grab a migration I prepared over here. So we're going to allow users to be able to like quotes. So this means that, you know, if we're creating a front-end interface, people will be able to click a little like button, for example, and then like a quote and say, yeah, that's my favorite quote too. So we're going to add this column likes to the quotes table. And we'll make sure we add the down migration too, in case we need to roll that back for any reason. So now we've got that migration in there. We're going to start up the server again. And we can see that the migration has automatically been run for us, which is great. And then we can now go ahead and head over to GraphQL again. And we're going to click this button here to refetch the GraphQL schema. So Platformatic DB is automatically figured out there's that new like column there. And so we need to refetch that so that the GraphQL schema is up to date in GraphQL. And I'm going to jump here and grab a new query. And this will allow us to actually get back some top quotes. So we're going to now go ahead and build out this query. So to do that, we're going to jump into the plugin.js. So over here, this was automatically added for us earlier by the CLI. We've got this plugin path, which has been referenced here. And here in the plugin, this is actually a Fastify plugin. So I mentioned the Fastify web framework, one of the libraries that Platformatic DB is built on top of. And this allows us to expose like full functionality and to go and actually customize things as much as we like. So we can see we've also got types coming in here automatically. And that's what was created for us earlier. We've got that global.d.ts. So even if you're not using TypeScript, you'll get type hinting in your editor based on the different entities you have, which can make it a lot easier to actually build things. So let's go ahead and actually extend this. So I'm going to grab a little bit of prepared code here and drop it in here. And so what this is doing, let me just reformat that. We'll pull the terminal down. And so here we've got this, we're extending the GraphQL schema. So there's that automatic GraphQL schema created by Platformatic DB. We're going to add a new query called top quotes that will return an array of quotes. So here then we've defined a resolver So in GraphQL, you have this concept of resolvers, which you need for either queries or mutations. And so what we're going to do now is we're going to return await app.platformatic. So Platformatic DB makes it automatically that you can access app.platformatic.entities, and then we're going to say .quote, and then we're going to call the find method. And this is one of those mapped entity methods, so we can then say where, and we can say where the likes are greater than or equal to 3. So the top quotes are going to be quotes that have likes more than 3 or more. So we'll save that, and you'll notice that the server is automatically restarted for us. And if we head back to our browser, refetch that, and then run get top quotes, there's no top quotes right now. And that's because if we actually go and run get all quotes, we'll see that there's no likes for this particular quote. So we need to go ahead and actually add in something else. So we're going to add another little piece of custom functionality. So here we've got this other little prepared snippet. We're going to add a mutation, and this will allow users to go and like a quote. So we can't have any top quotes if people can't like them. So here we're adding this mutation like quote, and it accepts an ID. So the ID of the quote that we want people to like. And we're going to go and add in a resolver for this as well. So we'll add in this mutation, and we're going to drop it in here. And cool. So we also have, as well as the entities, app.platformatic exposes DB and SQL, which are the underlying parts of databases. So it allows us then to go and actually write our own SQL query. So instead of working directly with the entities, we can do await db.query, and then we can do SQL. And then this allows us to actually go and write our own raw SQL. So inside of that, we're going to say update quotes, and we're going to set likes equals likes plus 1, where the ID equals the ID that's been passed through. And then we're going to return the number of likes. So that means that down here, we can then actually return the number of likes back from this mutation when somebody runs against it. So we've got this raw SQL query, which is like a level of abstraction down from the entities and allows us to build something a little bit more custom. So we'll save that, and our server's restarted, and we're now going to actually head back here. And if we go back and run get top quotes, we'll still see there's no top quotes. So let's actually go and run that mutation to like the quotes. We're going to drop that in here at the bottom. And now we can actually go and like that Wizard of Oz quote. Notice how we're passing through the ID 1. So we'll like that particular quote. So we like that quote, and it tells us there's 1, 2, and we'll do it again and again. And now if we go ahead and run get top quotes, we'll see that it's come back because it's got more than 3 likes. And so this is how we can actually look at extending the custom functionality that we have inside of Platformatic DB and building on top of it. So finally, if we want to actually do something standalone, if we don't want to use Platformatic DB, or if we outgrow the functionality that it provides and we want to do something really, really custom, then we can actually go ahead and use the Platformatic packages standalone. So the SQL mapper, the Open API, and GraphQL packages, which Platformatic DB are built upon, can all be used by themselves or combined in any way that we want. So that's everything from me, and we'd love it if you went ahead and gave Platformatic DB a try. Head over to oss.platformatic.dev. We've got a 2-minute quick start guide there, and we'd also love to hear your feedback. And so please come and join us in the community on Discord. And that's everything from me. If you want to drop me a message in the chat or find me over on Twitter at SimonPlend, be happy to answer any questions you have.
Nice, perfect, Simon. I really loved this. I didn't know about this, and I think we should also have some questions. So if we can answer to them and then we wrap up this episode of the Monthly Dev. I really enjoyed it, to be honest. So there are some questions. Like someone was asking, like, where are the endpoints in the code? I don't know if you.
Oh, where are the endpoints for the API? Mm-hmm. So there's no code generation. So in terms of, we had a couple of things generated, like the Platformatic DB config and the SQL, but the actual API is automatically generated. And so when you run Platformatic DB, if you run Platformatic DB start, it then automatically looks at your database and creates those endpoints. But there's no actual code for them for you to go and modify. But if you want to build something custom, as I've shown, if you want to add your own endpoints and customize things, you can then go and add them here. So here we just looked at GraphQL, but you can also go and add REST API endpoints. Unfortunately, I didn't have time to show that today.
We also this one, I'm also trying to following, so not sure if this question makes sense, but let's try so we understand together what's going. So this builds the API based on the DB query for you or not?
So if it, sorry, I didn't quite follow that. If it builds on the API query.
Yeah, I don't know if you can also read the question, but I say.
Okay, yeah, let me see
this
that. Yeah, so
API on the query automatically for you.
Cool. Yes. So what it does under the hood is it handles automatically generating queries. Yeah. So you don't see that necessarily when you're actually working on it, but you can actually go and in the next release. So we've got a release coming out in the next couple of days, and you'll be able to switch on logging and detailed logging. That will allow you to see all the SQL queries that are getting run when you call your API, and all the GraphQL queries and things too. So, but yes, exactly that. It's doing SQL queries automatically under the hood for you, and you can then build on top of that.
Okay, last one, which is more a comparing part. I don't know if we would like to answer this. Comparing to Azure, I don't know if you know the project. Mm-hmm. It says Azure you can trigger events, merge remote schema, or we have to build this with Fastify and Mercurius.
That's a great question. Yeah, Azure is a super powerful tool, and in terms of like comparisons, so we've got some new things in the work. There will be some stuff around like subscriptions in GraphQL, which will be coming in the near future. In terms of remote schemas, I'm not quite sure, but I can find out, and I'm happy to drop it in the chat after.
Nice, thank you for replying to this. These are the hardest questions. So let me remove this, and now I don't know if Dennis is still here. Can I invite you, Sabrina? Not or not? Okay, perfect, nice. So I really loved this episode, of course, because I know the speakers, but also I think they brought a lot of quality and value. So thank you so much, and I really learned a lot in this episode too. So thank you so much. Congratulations to all the speakers. Nice. So we are about to close this episode. If you want to drop something here, you can now. And yes, that's it. So before we leave, I'd like just to remind you something crazy that I've been doing for the last 3 weeks. So basically at daily.dev, we started basically an experiment of posting shorts on the company account. Some of you maybe noticed that, and let me share basically making a fool of myself. So we have like now a TikTok account, an Instagram account. We're trying to post something related to development. They are of course funny videos. They are not educational because I pretend to be funny, and I also drop the link if you want to support this initiative. And that's it. So now I'll share this. And in the meanwhile, I think some of you would like to say something before we close this one. And thank you so much, of course, to all the speakers. Dennis, would you like to give some final thoughts, final message?
Oh, just thanks for having me. It was a lot of fun. Definitely learned a few things too. It's always interesting to meet new people. It's the first time seeing Sabrina and Simon, so definitely good to see your stuff. I'll have to make sure to follow you guys on social media. Maybe I already do. I don't know. I'm not that active on Twitter, but good being here. Thank you.
Nice. I also sometimes I laugh because I've noticed that also the talks were connected because talking about PrismaDB, then machine learning from Sabrina. So we're trying to give Dennis some ideas about machine learning, and I love doing this because this is not scripted, not prepared, but it's good. It's a very good opportunity also for everyone to learn. You're always craving for new ideas and new things. So that's it. So yes, thank you so much. Yes, thank you. Good information. Thank you so much. Really enjoyed this episode. Great stuff. Also on point on all the questions. Thank you so much. We are at the end of this episode. And yes, have a nice day, everyone. I'm done for today. It's 6:30 p.m. here. For me, it's like midnight, so it's done. Perfect. Bye, everyone. Remember to check the speakers. We have the link in descriptions to their social media. So do that. Follow them. Really high quality today, and really loved that. Bye, everyone. Bye-bye.
Thanks, everyone.
Bye, everyone.
Bye-bye.
Thank you.